Now, dear students, next topic, that is conservation of mechanical energy with the example of free falling body. Suppose, as shown in this figure, the body of mass m, that is freely falling from the cliff, which one is at height capital H. So from this position it is freely falling. So its initial velocity, that is 0. Right? Now, when the body is at height small h, or the position which one is at height h, when the body is passing through it, suppose its velocity, that is vh, and finally when it hit the ground, its velocity, that is vf, then we can write the mechanical energy of the body at height h. So initial velocity, that is 0. So kinetic energy plus potential kinetic is 0, and potential energy at height h, that is mgh. When it is at the position which one is at height small h from the surface of the earth, then position h, that will give you the potential energy mgh, and suppose at that position the velocity is vh, then kinetic energy is half mvh square. When it hit the ground, then h equal to 0, so potential energy is 0. So potential energy is 0, so total mechanical energy at the ground, that is half mvf square. So here we can observe this thing: when the body is moving in the conservative force field from one position to another position, its kinetic energy is changing to potential energy and vice versa. Clear? But the total mechanical energy, that remains constant. That we can understand here. Okay? Now see here, if we compare these two equations, EH and E0, because at any position the mechanical energy is conserved, right? So EH equal to E0, so half mvf square, that is equal to mgh, mm will be cancelled, so we can write here Vf, that is under root 2gh. Clear? So in this way we can calculate the final velocity of the body, or velocity of the body when it hit the ground, when it is freely falling from height h. Okay? Now, if we compare these two, EH, E capital H, that is equal to E small h, then again we can prepare the equation for Vh, with the help of which we can calculate the velocity of the free falling body at any intermediate position, which one is at height small h from the surface of the earth. So mg capital H, that is mgh plus half mvh square, mm will be cancelled from both the side. So take this first term on left hand side, so g into capital H minus small h equal to half vh square. Make vh as the subject of equation, so vh equal to under root 2g into capital H minus small h. Clear to all of you? So here this one is the conservation of mechanical energy for free falling body. Clear?